I'm Ranga Karnam. I'm 10x certified in AWS, Azure, and Google Cloud as well. Our courses are helping thousands of learners do their cloud certifications in AWS, Azure, and Google Cloud. In this video, let's focus on DevOps. We'll talk about what is DevOps, what are the different elements that are part of DevOps. We'll also talk about different tools related to all the DevOps elements. We will talk about almost 50 different tools in here, and we'll try and cover the cloud platforms as well. We will look at different DevOps tools in each of the cloud platforms, AWS, Azure, and Google Cloud as well. So, are you excited to get a high-level overview of DevOps and understand the entire landscape? Let's get started. Now, before we get into DevOps related tools and all the things related to that, let's try and understand why we need DevOps. How did we evolve to DevOps, right? Whenever we talk about software teams, right? Whenever we talk about teams which are building software, there are a number of elements which are part of it, right? So you have the business team who are responsible for requirements. You have a development team, you have a test team, and you also have a operations team. So whenever we talk about DevOps, there are a lot of people who are involved in the entire development life cycle. And not just this, we also have a number of environments. So typically, whenever you want to take something live, it's not easy. You would actually need to first go to dev environment, a QA environment, stage environment, and then you would take it live to production environment. So there is a lot of process which is involved in taking applications live as well. It's not easy to take something live to production directly. Over the period of last few decades developing a lot of software, we realized that a few things are really important when it comes to DevOps. And I call them the three key elements of software development. Whenever we develop software, the most important part is communication. We talked about the fact that there are multiple teams which are involved, and communication between these teams is really important when it comes to building great software. Earlier with Agile, what we tried to do was to build the entire business, dev, and test team together, and we called it a Agile team or a Scrum team. And these teams worked in iterations to build software. This helped in improving the communication within the team. And with DevOps, the question is, why do we leave operations aside, right? The ops team plays a very critical role. Whatever happens in operations help you in deciding what to do next with your applications. The feedback from the operations team is very important for the business team, the dev team, and the test team as well. So why leave it out? Why not include it as well? That's the step which DevOps takes. With DevOps, we also bring in the operations team. So the more we improve communication, the better product we will be able to build. So the software which we build will be really good when we enable good communication between the entire software team. So that's the first element of software development. And in DevOps, we do it by bringing the entire dev, business, dev, test, operations, everything together. The second important thing that we realized over the few decades of developing software is that feedback is very important to be able to build great software. And that's the reason why you would see that these days we build software in iteration. There are a lot of steps in building software, right? We start with requirements. After doing the requirements, we do architecture, design, code, test, deploy, and finally operations. So there are a lot of steps which are involved in building software. So we start with requirements, we do architecture, design, code, test, deploy, and finally we operate the application in production. And we need to go through all these cycles for each piece of software you develop. So one of the most important things that we realized is that getting quick feedback helps you to build better software and also helps you to react very, very quickly. If I'm doing a code and let's say I'm committing it into version control, if I find out that there is a test failure for it a few days down the line or a few weeks down the line, that's too slow. We would want immediate feedback. If a business team writes a requirement and they don't get any feedback on it, then they do not know whether the users like that feature or not at all. So even the business team wants to get quick feedback on whatever requirements they are writing, right? So feedback is very, very important. And the best way to get quick feedback, what we have realized over the last few decades, is through automation. If you automate as many steps as possible in the entire software lifecycle chain, you would get quick feedback. So typical examples are, if you want to automate your unit tests, automating your integration tests, unite like your deployments, automating the provisioning of your infrastructure. So if you need to create an environment, you can automate that. Automating operations as well. So doing things like this will help you to get better at building great software. So this is what we found over the last few decades. Communication, feedback, and automation are really, really important. And as far as I'm concerned, DevOps is nothing but the next step in how we build great software. DevOps improves all these three: communication, feedback, and automation. We looked at how communication is improved, right? The communication is improved by bringing the DevOps team, by bringing operations into the mix. It's no longer about writing a document and throwing it away to the operations team. It's about becoming one team and taking entire ownership of the entire life cycle. That enables great communication. That's what great DevOps teams do. The second thing is feedback and automation. DevOps enables feedback and automation through a number of very, very important DevOps practices. Let's look at the DevOps practices right now. So DevOps practices. What are the important DevOps practices? The first very, very important DevOps practice is continuous integration and continuous deployment. Continuous integration slash deployment slash delivery. This is the number one practice. A little bit of this was also done in Agile. Continuous integration was the focus in Agile as well. DevOps takes this to the next level. What's the second practice, which is very, very important? Infrastructure as code. Let me get the right pen. So infrastructure as code. It's also called IAC. This is another very, very important thing that DevOps focuses on. Next important thing that DevOps focuses on is observability. You want to be able to get metrics from production. You want to be able to see what's happening in production. And the fourth one we try to do a lot is standardization. If you have microservices architecture, and if you have different ways of building a Python microservice, different ways of building a Java microservice, different ways of building a Node.js microservice, these applications become very, very difficult to maintain. We saw that there are a lot of things that are involved in taking an application live. It goes through a number of phases, and you need to go through all those phases for each of these different kinds of applications, and you want to automate them. Automating things becomes really, really easy when things are standardized. If you have different ways of deploying a Python application, a Java application, and things like that, it becomes really difficult to manage things in production. The operations job becomes really, really tough. That's where standardization is also very, very important practice as far as I'm concerned, as far as DevOps is concerned. Now, let's quickly look at these practices and look at the tools which are related to these practices as well. Let's get started with talking about continuous integration, delivery, and deployment. Let's go to 1. So what we want to talk about is CI, CD. Let's start with CI. CI is very, very simple. A developer commits a piece of code to version control, right? So you have a version control system typically. What is the most popular one? The most popular one is Git, like GitHub, GitLabs. Each of the cloud providers also offer their own Git repositories. So you might be storing your source code in any of them. As soon as a developer commits a piece of code, what you want to do is to check if the source code is good or not. The first thing that you would do is to compile code. You want to compile. Next, you want to run unit tests. If you have any automated integration tests or things like that that you can run them as well. And after that, you also want to do a static analysis of the code. So you want to check whether all the coding standards are being met. And you want to see if you are able to build a deployable unit. If your end goal is to create a Docker image, you want to create a Docker image and see if you are able to create it properly. If you want to do security tests, if you want to actually, like, let's say you have any static security analysis that you want to perform, you would want to do that as part of your, as soon as a piece of code is committed. So these are all the things that you would want to do in as part of your continuous integration cycle. So when a developer commits a piece of code in, you'd want to first see if that piece of code compiled. Next, you want to run the unit tests. Next, you want to check the coding standard, static analysis. You want to build a deployable unit. Is it working fine? You want to check any security related things that you would want to check. And only then you would want to go ahead and deploy your piece of code. So this part of it, where we are actually checking the code as soon as it is committed into version control, is called continuous integration. What is the advantage of continuous integration? This gives quick feedback. If there is any failure, a developer will know it within a few minutes. If your continuous integration cycle is fast, then within a few minutes, a developer would get an email if something is wrong, or if everything is fine, then he doesn't really need to worry about it at all. So continuous integration helps you to get quick feedback whether the code is meeting all the standards, whether it's meeting all the static security guidelines, whether you're able to build a deployable unit, whether your unit tests are all succeeding, and things like that. That's continuous integration. The next step is you'd want to be able to deploy your application to an environment as well. Maybe you have a test environment. So you would actually deploy to test environment. So deploy to a dev environment, for example, right? So if everything goes fine, you'd also want to be able to run a few system tests. So once you deploy to a dev environment, you might want to run a few automated tests as well. And you might want to promote it to other environments and finally deploy to prod. A lot of times, the entire deployment production is not automated. Some of these steps might involve manual approvals. You might want to do manual testing. You might want to get approvals from your UAT team. So there are different people who are involved in making decisions whether you can actually take a piece of software live. So a lot of enterprises don't want to directly automate the entire releases to production. That's why what they do is they stop the automation cycle probably with a dev environment or a test environment or a staging environment. So they deploy to dev automatically, and probably they would run unit tests also, but they don't directly automate the deployment to production. This is called continuous delivery. So this is CD in terms of continuous delivery, where you would actually deploy it to one of the dev environments or the test environments. So as soon as somebody commits code in, you do the CI cycle. If everything is fine, you build deployable unit and you would deploy it to a test environment only. You will not deploy it to a production environment. This is what is called continuous delivery. If you are in an enterprise where you actually run the system tests automatically, if they are successful, you automate the deployment to QA stage and you run the specific test for each of those automatically. And then you automate the entire thing even to production. So if you automate the entire deployment starting from dev, running the tests, and taking the software to production, this specific thing is called CD, but continuous deployment. So you are automating the entire life cycle of your software, starting from your build, your static analysis checks, your code quality checks, your testing, deploying to an environment, testing in a deployed environment, and maybe UAT tests, automating everything and taking it to production. So CI/CD are different just in where you stop. So CI is basically about checking if your software is buildable, meets all the static analysis, runs all the unit tests. That's CI. CD is to deploy it to an environment, your deployable unit, you build it and deploy it to an environment. Delivery is focused on, continuous delivery is focused on deploying it to a dev or a QA or a test environment, right? So the last part of it, the continuous deployment, is actually automating the entire life cycle from start to end. Now, whenever we talk about these things, there are a lot of tools which are involved. We already talked about the version control tools. What are the different version control tools which are present? Git, GitHub, GitLabs. Each of the cloud platform has different version controls. Earlier, we used to use SVN. This is Subversion. This is no longer used a lot. So these are all the source control or the version control tools which are very, very popular. Now, to compile your code, there are different ways, right? So if you are actually using Java, you might use a Java compiler, Python. Like the compilation would differ in different places. And to be able to run all these things, you might make use of a build tool, right? So the build tool, which is used on Java side of things, it might be something like Maven or Gradle. Oops, it's a G, Gradle. Like if you are in JavaScript side of things, you might use npm. So there are a variety of tools which can be used to do the build. Unit testing frameworks also vary based on what you are using. If you're using Java, it might be JUnit, Mockito, and things like that. If you are using JavaScript, then you might be using Jasmine or a lot of Karma or a lot of other things which would be used to run unit tests and write unit tests as well. And if you're using Python, you might be using PyTest. One of the most popular tools to do static analysis is Sonar, right? So Sonar is one of the most popular ones. It does a lot of checks on the code and gives you a report saying, hey, this piece of code is not good, this piece of code is good, and things like that. So these are some of the important tools that are typically used as part of your CI/CD tools. As part of your CI/CD pipelines. Now, to be able to run CI/CD, you need some kind of a tool. If you look a few years back, the most popular one was Hudson. From Hudson, we moved on to, I would say, Jenkins. So in the last 5 years, I would say the most popular one to do CI/CD, to execute the pipelines and all that, is Jenkins. And now we are slowly moving towards the cloud. And as we move towards the cloud, the most popular one, as far as I'm concerned, is Azure DevOps. In Google Cloud, also, you have Cloud Build, which can be used to do CI/CD. And even in AWS, you have AWS Code Pipelines, you have AWS Code Build, you have AWS Code Build, Code Deploy, Code Pipelines. So those are all the things which are present in AWS. So these are all the tools which are related to CI/CD. Now, if you ask me which one to learn in 2022, as I'm recording this specific video, even though today a lot of enterprises are still using Jenkins, I would think in 5 years' time, Jenkins will not be used as much. I would think the best tool to learn is based on which cloud you are learning. And if you are not sure which cloud you are going to learn, then I would say get started with Azure DevOps. I would say Azure DevOps is the best recommended one, as far as I'm concerned, to learn if you want to learn CI/CD today. One other important thing I would recommend with respect to CI/CD in these days, I mean, the last couple of years, this evolution has happened, it's GitHub Actions. So GitHub Actions allows you to do CI/CD on code which is stored in GitHub. So that might also be a great place to start learning CI/CD. So today I would say I'm kind of split between Azure DevOps and GitHub Actions if you want to learn CI/CD. So that's about continuous integration, continuous deployment, and continuous delivery. Variety of tools, variety of processes, everything aimed at getting quick feedback. You would want to get, if a unit test is failing, you'd want to know as soon as possible. If a static analysis check is failing, if you're not able to deploy to an environment, if you're not able to build a deployable unit, you want to know each one of those as quickly as possible. That's the goal of continuous integration and continuous deployment. Now, let's quickly move on to the second one, which is very, very important. Usually, infrastructure as code is neglected. Infrastructure as code is not given the right amount of prominence when it comes to software. This was okay while we were running applications in our data center, but in cloud, infrastructure as code is very, very easy. Why do we need infrastructure as code? Because whenever we create a cloud platform, a cloud environment, there are a lot of things that are involved. Let's just take an example in here. Let's say I'm setting up a simple full stack application, right? So let's say I'm doing it in the cloud. Then what is the infrastructure I would need? First thing is I would need to create a VPC. I would need to create a subnet. I would probably need to create another subnet. I would probably want to have a database in a subnet. I want to have a database in a private subnet. I'd want to probably have a virtual machine or a managed service here. I would want to deploy my application here. So this is the thing which I would want to create. I would want to create the right rules, allowing the right amount of traffic in here. And not just this should be repeated across multiple environments. Typically, we have dev, QA, stage, production. So you want to do this across multiple environments. And doing this manually is very, very time consuming, very, very error prone, and not repeatable. So it's a lot of manual effort if you do everything manually. And that's why you would want to automate as many things as possible. Whenever we want to create an environment, whenever we want to deploy a piece of code, there are a lot of steps involved. First is you want to provision infrastructure. So provision infrastructure. That's the first step. You want to create a VPC, you want to create a subnet, you want to create a specific VM, you might want to create a database. So that's provisioning infrastructure. The second step is what is called configuration management, where you might want to install a specific kind of OS, or you might want to install a security patch, or you want to install a specific kind of application software. The third step is the deployment step, where you deploy your specific application. So whenever we talk about creating and deploying infrastructure, there are multiple steps for each environment as well. It's not like you can directly deploy. So these steps need to be followed. And after provisioning infrastructure, you do configuration management, and then you would deploy. And this deployment might happen continuously, right? But before you'd be able to deploy software, you'd want to go through these two steps. You want to provision infrastructure is basically creating the VPC, subnets, your database, creating the rules and all that stuff. Configuration management is to make sure that you have the right configuration for the resources you have provisioned. If you have provisioned a VM, you might want to install the right software on it. You want to make sure that it has the right security patch installed on it. If you look at the technology space today with respect to provisioning infrastructure, there are a lot of cloud-specific tools, and there are a lot of cloud-neutral tools. Cloud-neutral tools help you to deploy infrastructure in multiple clouds, AWS, Azure, Google Cloud, and even maybe in your data center as well. So if you look at the provisioning infrastructure space, the most popular tool today is Terraform. Terraform uses something called HCL, HashiCorp. Actually, it's configuration language. HashiCorp configuration language. And the alternative for Terraform is something called Pulumi. Pulumi is something recent, which is from the last couple of years. This helps you to write your code to provision infrastructure in Java or Python or C#. So instead of making use of a customized domain language like HCL, Pulumi makes use of a language which you know of. So you can make use of the programming constructs you know of to provision infrastructure. Today, if you look at the market today, I would say it's 80 Terraform, maybe 5 Pulumi, and 15 would be using cloud-specific infrastructure provisioning tools. Each of the cloud platforms have their own tools. AWS has cloud formation. Cloud formation scripts are really, really tough to maintain. And that's why AWS has also now come up with a new one, Cloud Deployment Kit, which is very, very similar to Pulumi. If I am like at a general level, I would say AWS CDK uses the same approach as Pulumi. You can write programs in your favorite programming language to provision infrastructure. So that's AWS. In Google Cloud, also there is Google Cloud Deployment Manager, and Azure also has ARM templates. So you have ARM templates which can be used to provision infrastructure. And Azure also provides an alternative approach, which I like, which is Bicep. Uh, I would say Bicep is very, very similar to Terraform in the approach. Bicep also creates a custom domain language. It provides its own language, a custom domain language, which you can use to provision infrastructure. So these are all the options which are present in the provisioning infrastructure space. If you ask me which one I would recommend today to learn, it would be Terraform. So Terraform would be the best bet as far as I'm concerned if you want to learn provisioning infrastructure in any of the clouds. Or you might, if you are only specific to AWS, I would say AWS CDK. And probably if you are in Azure, I would say Bicep. If you are in Google Cloud, I would still say Terraform. Terraform would be the recommended one for you to learn. So that's provisioning infrastructure. Each of the cloud platforms also provide configuration management tools. What do configuration management tools do? Let's say I have hundreds of VMs and I would want to update a software on it or install a software patch on it. Installing it manually takes a lot of time. That's where you can go for configuration management tools. These help you to update a patch on multiple VMs at the same time. If you go traditionally, you would see that Ansible, Chef, Puppet, these are some of the popular configuration management tools. Today, I would say with the emergence of cloud, I would prefer learning Ansible as the configuration management tools. There are cloud-specific configuration management tools also, like the AWS, Azure, Google Cloud. They also offer their own specific cloud configuration management tools. But today, I would recommend going with Ansible as the configuration management tools. Chef and Puppet were popular earlier, actually even more popular than Ansible. But with the emergence of cloud, the popularity of Chef and Puppet has reduced a lot. The main drawback of Chef and Puppet is that if I want to manage a VM, then you need something installed on each of these VM. So you need to have a small agent installed on all of these. And when we talk about the cloud, installing agents and things like that, you really don't want to do that. You want to keep things as simple as possible. And that's why we go for Ansible typically, because Ansible does not need anything installed on the VMs. You just need to identify these VMs, A, B, C, D, E, F, G, H, and Ansible can manage them for you. So that's the reason why Ansible is becoming popular. And we already talked about CI/CD earlier. So whenever we talk about infrastructure as code, today I would recommend you to learn Terraform. That's the number one thing. If you are specific to AWS or Azure, then you can go for AWS CDK or Bicep. In the configuration management space, I would recommend you to focus on Ansible. Now, until we focused on building applications, deploying applications, creating environments, and things like that. In DevOps, the focus is on the operations team. And the operations team is responsible mainly for observability. What is observability? There are three very, very important parts to observability as far as I'm concerned. One is metrics. What is the CPU utilization? What are the application metrics? Logs are very, very important as well. If you want to debug a problem, you want to be able to find the logs. From the log, you'll be able to find out why something has occurred. What is the reason? The third thing, which is very, very important, is tracing. These days, we are talking about microservices architecture. You have a number of microservices present which communicate, and that's how you achieve your features. Now, if there's a problem, you want to find out what path the request took. And that's where tracing really helps. So metrics give you specific instance. What's the metric? A CPU utilization, a database CPU utilization, or how much time it took to query something, right? That's metrics. Logs help you to identify what's happening behind the scenes by looking at the logs. And tracing helps you to put things together. Across microservices, I want to find what's happening. That's where tracing really helps. If I go a little while back, there were independent tools, independent standards for metrics, logs, and tracing. There was open tracing, open sensors, open metrics, and a lot of different kind of tools. But over the last few years, everything has standardized, and almost every cloud provider today adheres to an open standard called open telemetry. So if you'd want to build good observability into your application, if you want to be able to store metrics, like create metrics, store logs, tracing, all that you need to do today is to integrate a library which is related to open telemetry into your application and deploy it to the cloud platform. And once you do that, the cloud platforms automatically recognize your metrics, logs, tracing, and they store it to the corresponding cloud service directly. So if you have an application, for example, if you have an app and you add a open tracing, open telemetry compatible jar or deployable unit into it, and you deploy it to a cloud platform, right? So once you deploy it to a cloud platform, all the metrics, logs, and tracing from your application go directly to the cloud specific tool. So in each of the cloud platforms, they have different tools for metrics, logs, and tracing. To that specific service, all the data would be stored. Now, what are the different metrics, logs, and tracing services which are present in different cloud platforms? In AWS, for metrics and logs, we make use of CloudWatch. And for tracing, you make use of X-Ray. In Google Cloud, you have cloud monitoring for metrics. You have cloud logging for logs and cloud tracing for tracing. And in Azure, all these three are provided by Azure Monitoring. There is a part of Azure Monitoring which is called logs, which is for logging, and there is something called tracing for tracing. So these are all the services which are present in different cloud platforms. However, integrating with them has become really easy because nowadays almost every cloud platform adhere to the open telemetry APIs. So if you integrate open telemetry related things into your application, send the right metrics out, and deploy the application to the cloud, you'll be able to see those metrics in AWS, Google Cloud, and Azure. The important thing to understand about observability is observability earlier was only about identifying problems from production. But today, observability is much more. You would want to influence the decisions business make, what kind of requirements you would want to build into your application based on what is happening in production, whether users are making a specific use of a specific feature or not. What is happening in production today? You'd want to take that input and you want to drive your future decisions. That's where observability is very important. It's not just to find problems, but also to decide your future direction. You want to find out things which are happening in production. And that's the reason why open telemetry came into picture. Open telemetry is now a consolidation of everything around the observability space. There are actually a lot of other open source tools. There are commercial products that are coming up in the open telemetry space as well. If you look at like CNCF, it's one of the foundations which focuses on containers, container orchestration, and related tools. If you look at metrics, the most popular tool today, I would say, is Prometheus. Like the open source, if you look at open source, like CNCF, for example, for metrics, Prometheus is the most popular one. AWS also has a managed service for Prometheus. It's that popular. If you want to go for logs, then I would say FluentD. It's part of CNCF, and it's one of the popular log tools. And for tracing, I would prefer going for Jaeger today. So Jaeger is one of the popular uh, tracing solutions. Earlier it was Zipkin. I would say these days I would prefer going for Jaeger. So if you are starting in the observability space, I would recommend you to explore the open telemetry. Like that's one thing which you would want to explore. And also, if you are in the cloud, you can also explore open telemetry integration with the cloud specific services in your specific cloud platform. So those are the things I would recommend you to focus on when it comes to observability. Now, the last part, which we talked about earlier, is standardization. We talked about the fact that microservices architecture are becoming very, very popular. And when we are having microservice architectures, we might have applications built in multiple different languages. And you don't want different deployment procedures. You don't want different monitoring procedures. You don't want different ways to create infrastructure for different microservices. Once you standardize on it, it makes it very, very easy. And that's where there are two tools which are really, really playing a very, very key role. Docker, and the other one, do you want to guess it? Yep, it's Kubernetes. So these two tools are revolutionizing how DevOps is done because they simplify it a lot. Let's start with Docker, right? Irrespective of whether you create a Python, irrespective of whether you are creating an image for a Python application or a Java application or anything, once you have a Docker image, the way you deploy it would be the same. Whether I'm deploying it to my desktop local machine or I'm deploying it to cloud, any of the cloud platforms, AWS, Azure, Google Cloud, they have a lot of services to run containers, or you are deploying it to a data center. Even in the data center, all that you need to do is to have a container runtime, and you'll be able to deploy a Docker image or a container image to it, right? So these things, like the Docker image, can be deployed the same way to a lot of places. So it brings in a lot of standardization. You don't need to worry about customizing things depending on the type of application you are deploying. And the great thing about the Docker image, once you make use of containers, container images, and things like that, is that getting metrics, getting logs, getting traces out of this, getting all the standard things that you'd want for observability becomes really, really easy as well. So that's the reason why Docker is very, very popular. Docker is also lightweight compared to virtual machines. So it does not consume as much CPU memory and things like that. So you'll be able to run a lot more Docker containers than virtual machines. So Docker is becoming really, really popular. Over a period of time, instead of Docker, we are now talking about Open Container Initiative, right? So there are two very, very important parts of Open Container Initiative. One is the definition of an image, and the next is the definition of a runtime. Earlier, Docker was the most popular container platform. Even today, I would say Docker is one of the most popular ones. But over a period of time, we evolved to more of an open standard. We just did not want to depend on Docker. We wanted some kind of an open thing so that everybody can adhere to that, and a lot of other tools can be built around that specific standard. So OCI defines a standard for how you can build a Docker image and how a runtime should work, how a container runtime should be able to identify the image and run it. So it defines standards for both. As long as your application image adheres to that, you can run it on a OCI runtime. So if you build a OCI standard image, you'll be able to run it on an OCI standard runtime. Obviously, Docker is compatible for each of these. Docker images can run on any open contain OCI runtimes, right? So there are other things like Rocket, and also there are other runtimes which are present, which are popular as well. So Kubernetes makes use of something called CRI-O, which is the runtime which is used by Kubernetes, which is what we are going to talk about next. So once we were able to standardize around how we build Docker images, the next thing which became really, really important is standardizing around a container orchestration framework. Why do we need a container orchestration framework? Typically, whenever we go to microservices architecture, there are a lot of non-functional requirements, a lot of technical requirements. So you would want to be, let's say I have a microservice 1, M2, M3, and so on and so forth. You don't want to hard code the address of M2 in M1. You don't want to hard code the address of M3 in M2. That's why you would need something called service registry. Service registry helps you to decouple microservices. If microservice 1 wants to find out where microservice 2 is, it can ask the service registry, hey, where is microservice 2? And then once it gets the response back, it can make the appropriate call to microservice 2. So this feature is called service registry. Once you have, each of these microservices can have multiple instances. So you'd want to be able to identify when to scale them. Like you want to have features like auto scaling. You want to be able to scale up, scale down based on the load. You'd want also load balancing. You want to be able to load balance between the active instances of a microservice. You'd also want centralized configuration. You have a lot of microservices. You have a lot of configuration. So you'd want to be able to configure everything in a centralized way. Maybe you want some kind of a feature to store your application configuration, how to connect to a database. You want to be able to store secrets and all that stuff. And it's also very, very important to have self-healing capabilities. What is self-healing? Let's have 3 instances, and this instance ran out of memory. I want to be able to detect that this instance ran out of memory, remove that, and create a new instance. This is what is called self-healing. You want health checks and all that kind of stuff to identify the unhealthy instances and replace them as well. And you'd want release management strategies. Whenever we talk about microservices architectures, there are hundreds of releases happening every day. And whenever there's a release, you don't want the application to be going down. You'd want multiple release strategies. Let's say I have 5 instances or 10 instances of an application, right? So I don't want to deploy the new version to all the instances at the same time. Probably first thing I would do is to release the new version to just this instance, and then test it. If it's fine, then I would want to release it to other ones. This approach is called canary approach. There are a lot of other deployment approaches as well, blue-green deployment, for example, and a lot of others. So you'd want flexibility with your releases, and these are all the features that a container orchestration platform would provide you with. A container orchestration platform typically manages a cluster. So you have a cluster with a number of nodes. So typically in Kubernetes, you have a master node and you have worker nodes. So you have a number of nodes. The worker nodes is where all your applications run, all your microservices run, and the container orchestration tool is responsible for managing the cluster. The input you would give to the container orchestration tool is something like, okay, I would want to run microservice 1, I would want 4 instances of it, and this is the configuration. I would want to run microservice 3, and I would want to auto scale it based on the load which is coming in, and this is the configuration for it. So you just give the right microservice Docker images or the container images to container orchestration tool. The container orchestrator tool can identify what's the right place to put it on the cluster. The container orchestration tools also is responsible for all these features. If a microservice container instance is not healthy, it will be able to identify it. It is also responsible for deploying new releases. If I would want to upgrade M3 from, let's say, V1 to V2, all that you need to do is to say to container orchestration, go to V2, and this is a strategy I would want to make use of. So you can see that irrespective of whether it's a Python microservice or Java microservice or whatever, everything becomes standardized. You would deploy it the same way. All these nodes, all the applications which are put in here also can generate observability metrics the same way, because they are all container images. We can get observability metrics, and we can send them out to the cloud specific service as well. And you can use things like Istio. Like Istio is a concept called service mesh. Service mesh is the concept. Whenever you have common features that you would want to implement across multiple containers, multiple microservices, that's when you go for a concept called service mesh. And Istio is one of the most popular frameworks to implement service mesh. So in Kubernetes, you make use of Istio and you get all the common features at single place. So Kubernetes is very, very important when it comes to DevOps. It helps you to simplify a lot of different things. And that's why you would see that Kubernetes is today almost called the OS for the cloud. A lot of enterprises are making use of Kubernetes to manage their clusters and to manage their deployments. And Like there are Kubernetes implementations available everywhere. If you look at cloud, GKE is the most popular one, Google Kubernetes Engine. AKS, Azure Kubernetes Service. EKS, Elastic uh, Service for Kubernetes. I guess this is the AWS service. You also have other implementations. OpenShift provides a multi-cloud implementation. I mean, you can use OpenShift and run your Kubernetes clusters and manage Kubernetes clusters which are running in multiple clouds. Also, there are a lot of other options, other commercial offerings around Kubernetes as well. So you'd see that Kubernetes makes microservices architectures easier, and also Kubernetes managed Kubernetes services are available in different cloud platforms. So setting up a Kubernetes cluster is no longer as hard as it was earlier, and Kubernetes helps you to standardize everything. So over the last few minutes, we looked at a lot of details related to DevOps. We started with continuous integration, continuous deployment. We talked about continuous integration, continuous deployment, continuous delivery, and we moved into infrastructure as code, where we talked about provisioning infrastructure and configuration management. And we talked about observability, where we talked about metrics, logs, tracing. And at the end, we talked about standardizing, Docker and Kubernetes. If you ask me what are the top 5 DevOps tools to learn today, I would say start with Docker, go to Kubernetes, and then probably play with Azure DevOps, and then probably I would recommend you to go to something like Terraform to understand infrastructure as code. Now, Azure DevOps might be optional in a way. Probably you want to also explore GitHub Actions as an alternative for Azure DevOps. So those would be the important things as far as I'm concerned. Whenever you talk about DevOps, try and also understand a little bit about OpenTelemetry. I think OpenTelemetry is a great initiative, and I think it has a lot of scope to be used across the industry. I foresee almost every cloud provider, almost every application kind of using OpenTelemetry in some way or the other in the near future. So there you go. That's kind of the overview of the entire DevOps landscape. This was a very, very tough video for me to create because there are a lot of tools that I needed to remember to get this right. But I hope I had done a good job in remembering most of the things and getting these across to you. If you are interested in learning AWS, Azure, or Google Cloud, or if you are interested in learning DevOps, I would recommend you to check out our courses. If you are starting with DevOps, if you are new to it, and if you want to explore DevOps, we have a course called DevOps for Beginners. That might be a great course for you to pursue. If you have no idea about the cloud and if you want to get started with the cloud, we have beginner certification courses in each of the cloud platforms, AWS, Azure, and Google Cloud as well. In AWS, I would recommend you to start with Cloud Practitioner. In Azure, I would recommend you to start with AZ 900, which is Azure Fundamentals. And if you're going for Google Cloud, I would recommend you to start with Google Cloud Digital Leader. If you are anywhere related to IT, cloud and DevOps are must know. And that's the reason why I created this video, where I wanted to give you a quick overview of everything which I had learned about DevOps, right? So we had actually created similar videos giving you an overview, a 50-minute or 60-minute overview on AWS, Azure, and Google Cloud as well. So go ahead and check them out as well. And I'm sure you had a lot of fun. I'll see you again. I'm sure you had a great time watching this video. Do not keep it to yourself. Tell your friends and tell YouTube as well. How do you do that? Like, share, and subscribe. If you're looking to get cloud certified, check out our cloud certification courses in AWS, Azure, and Google Cloud. And do not forget to check out the other videos in this series of videos on cloud fundamentals. If there is a cloud topic that you're feeling it's very, very difficult to understand, do post it in the comments and we will make it simple for you. I'm sure you had a great time watching this video, and I'll see you again very, very soon. Until then, here's bye from Ranga at In 28 Minutes. See you soon.